Um, Hey everyone, this is Maths Guy channel here, and today we're going to be going through discrete random variables. So this will be a quick review of probability and that sort of thing. So a random variable is a value that you can get from a random procedure. And from here we can split off data. So like information into two types. So things that are categorical, things that are numerical. The difference is sort of self-explanatory. With category, gives categorical in categories, so it's like sort of classified, and even in numerical, it's involving numbers. So this will be more towards ordering. So after this, categorical and numerical can be further split up into two. So in this video, we're going to be only focusing on just numerical for now. So from numerical, you can split it up further into what's called continuous and discrete variables. So continuous are things that take measurements, so things that are weights, heights, times, that sort of thing. And discrete are things that are countable, or things that are usually whole numbers, things like how many apples are in a bowl, or how many coin tosses, that sort of thing. This is a quick refresher. So when you have notation, you'll see this. You have here PR capital X equals X. So the capital letter is the variable, and the small x is the amount of times. So you can have like here, X is the number of times you get tails flipped on a coin. And let's say for example we toss this coin 3 times, so you can get 0 tails, 1 tail, 2 tails, or all 3 tails. So this would be PR. If you want to write down probability of X of getting 0, you write PR capital X equals 0, or PR X equals 1, 2, 3, etc., etc. So in this, as you can tell, like flipping a coin, that sort of thing. This is an example of discrete, so it's countable. You can count like, I did 1, 2, 3, or 0 tails. And a quick refresher. PR X dash, so X dash is complement, is the same as 1 minus PR X. So you have probability of X, so what's the probability of that happening? And you have complement, so what's the probability of that event not happening? And also, when you're doing probability questions, sometimes you'll also like draw like a tree diagram. And rather than writing, so let's say for example, I'm rolling a dice twice, and I want to calculate the probability I'll get a 6. So rather than writing all combinations 1, 2, 3, 4, 5, 6, and for each of the 6, writing 1, 2, 3, 4, 5, 6 again, what I can do, for example, is if I want to find the number 6, I get probability getting a 6, probability of 6 dash, so probability this to 1 minus probability of getting a 6 or whatever. And for discrete data in particular, some of the properties are that the probability has to be between 0 and 1. It it has to be between 0 and 1, and it can also be 0 and 1 as well. And it says here, there's some this notation might be weird, but what it's saying in essence is that if you add all the probabilities together, you get 1. So here, if we go back to the example up top, X equals X, and the capital X be the number of times you get tails. The probability of getting 0 tails, probability, if we add up the probability of getting 0 tails plus 1 plus 2 plus 3 tails, all of it should equal 1. Here, just as a side note, you can have what's called a uniform distribution. It's where you're getting, it's like for example you're trying to work out the probability of getting a certain event, like a number on a dice or something. A uniform distribution is just where all outcomes are equally likely. So if I have a dice, what's the probability of getting a 1, 2, 3, 4, 5, 6? And then if you keep doing that, since all of them are equally likely, that's just an example of uniform distribution. And yeah, that'll be all.